Okay, welcome back to the Kart Racer game development series. Today we're going to be doing some coding. So we're going to be making it so that when we use the keyboard or the gamepad in Unity, when the game is playing, it will control both the actual physics engine components of our vehicle and also the graphical components. So what that means is we have these wheel colliders that we created last time. These are sort of invisible components that are actually going to do the driving. But if we enable these colliders to start rotating, or actually what they're doing is they're applying a torque, and so that torque will make the vehicle move overall. The rigid body component of the car itself will move. But the wheels won't turn, the steering wheel won't turn, they won't steer side to side, so we're going to have to do that as well to make the car look a little bit more realistic. So before we get started on that, though, I just want to point out a few little changes that I made as a result of my mistakes in Blender. So sorry about that. I made some mistakes in Blender. And so going into the geometry here, I'm just going to show you what I've done so that you can match that exactly. So going just through all of these wheels here, if you look at the left front wheel, you'll notice that the rotation of the parent, this is just the empty object that only has a transform, it's -90 in the Y, and the wheel below it, you can see that it's been basically zeroed out, basically default components, except that in this case I have flipped that in the Z direction. Okay, so that's going to flip it in this direction. Okay, and then the right front wheel, same kind of deal. You can see that we have a -90 rotation in the y-axis, and the child object just has a completely default because this one didn't need to be flipped around. And the reason why I've done this is so that now if I take the two wheels and I rotate them in a positive direction about the z-axis, they're now going to spin in the same direction, which is kind of a different direction for each of these two wheels. Alright, now going to the left rear, it's a pretty similar story. We have -90 in the parent, and in the left rear we have the -1 in the z-axis here. Okay, otherwise everything else is default. No position, no rotation, and 1, 1, -1 for the scale. For the right rear, we have a 90-degree rotation. I must have made some kind of a mistake in Blender that requires that to be so. And then we have the right rear wheel, which is rotated 180 degrees in the y-axis here. Okay, so anyway. Okay, and I also learned something new last time. So before, when we were using the WASD keys to do the fly-through mode, I was currently in orthographic mode. Which, if you use the WASD keys in orthographic mode, they look a little bit bizarre, and I really didn't know what to make of that because I just don't use orthographic mode very often. So. Anyway, you can see what happens when I go, I'm just pushing W, for example, to theoretically move closer to this object, and it doesn't really do what you might expect. But if I go out of orthographic mode and I hold the right button, I can zoom in, I can zoom out, I can look at it from different angles. This is the way that you're normally going to be using the Unity window, so if you're in a 3D game, just keep it in perspective mode. Okay, so we're going to need two scripts on our car here. I'm not going to put any scripts on the wheels themselves, but up here, our basic cart, and perhaps this isn't the best name for it, let's call this the cart. And so we have just the rigid body and the box collider. If you don't remember what a rigid body is, that's basically the physics component that's going to keep track of our object and within the physics system, so things like various forces, including gravity. And then we have the box collider, which is going to make sure that we don't intersect with other objects. So this box collider is going to make sure that we don't fall through the floor, particularly when we have our springs enabled on our wheels a little bit later. Then we make sure that if we fall down from a really high height, the springs may not be enough to stop us from crashing into the ground. We don't want our car to disappear, clip through the ground, so we'll actually put a box collider around our object here. Okay, so I'm going to actually create two scripts for this purpose, and the reason I'm doing that is because I want to create a script that's going to do the main controlling, the rotation of the wheels, the steering, all that stuff, turning the steering wheel, and moving the wheel colliders, actually making the car go at a relatively high level. And then the other component is going to keep track of the player's input, the user's input. So the user will be using the keyboard or the mouse or the gamepad. And this way, by keeping these two things separate, I can reuse the controller component on an AI vehicle later on. Okay, so I'm going to click on Add Component. And actually, you know what? I'm going to keep things nice and organized. I've been doing a terrible job so far. This game eventually is going to have lots of components. So what I'm going to do is I'm going to create a folder down here. So I'm going to go to Create Folder, just right click in this Assets area down here, do Create Folder, and I'm going to call that Scripts. I'm going to go into that folder and create a new script. So I'm just going to right click, go to Create, C# Script, and let's call the first one the player input. And this will be a really simple script. And I'm just going to drag this script onto our cart. Oh, it's still compiling. Sometimes Unity is compiling. So it built some default code in there. You can see the default code here, and it was still building it at the time. Okay, so I'm going to drag that onto the cart. And now if I click on the cart, you'll see that I have a third component, not including the transform that's always there. And let's just double click on this to open it up in Visual Studio. Now, as part of my workflow, I tend to like to use different workspaces and flip back and forth between the workspaces. So you don't have to do this, but I'm going to move this Visual Studio window over to my other desktop here. So I'm going to switch between those. Okay, so you can see that'll allow me to switch. You can switch in some other way if you want. Okay. Believe it or not, I do have the rights to Visual Studio, so guess I just didn't register it yet. Okay, so anyway, that's one script, and I haven't done anything with it yet, but let's create another script at the same time, just to make our job a little easier. So I'm going to call this the cart controller, and let's give that a second until it shows up here. That means it's compiled, and we'll drag that onto our cart as well. And I think while I'm at it, I will also double click on this script. You can double click it here or there, it doesn't matter. Alright, this is our auto rotator script from before. I'm going to close that, we don't need that anymore. Okay, so I think what I'll do, I'll start with the player input script. We don't really need these first couple of lines here. And I like my curly brackets on the previous line. Just going to delete everything. Okay, so let's start really simply. Now I need to make sure, because this code is going to depend on using our rigid body, because I'm actually going to cause the vehicle to move, I'm going to make sure that we have a rigid body. This particular component doesn't use it, but I do want to make sure that I have it. So in order to do that in Unity, you just put an annotation up here saying require component, and then you pass to that require component which component you need, and this is going to be a class name. So we're going to need two things. We're going to need a rigid body, and I'm also going to need, so just copy that line and we'll say a cart controller. Now this actually has two effects. Number one, it'll generate an error if we have an object that doesn't have these components but does have a player input component. But two, if I drag player input onto a new object, it'll automatically create these two components for me on that object. You know, the settings won't be set up properly, but at least it'll auto-generate it. Okay, so this particular component is only going to use the cart controller, so I may very well delete the rigid body requirement up at the top, but we'll use that in the other script. Okay. So inside this script, we are going to have a few parameters that we can configure. There are two ways that you can make configurable parameters in Unity. Number one, I can make a parameter that's public. So I can say public float acceleration. That's one of the parameters that we're going to need. And the acceleration is basically how fast are we going to get. How fast are we going to accelerate? And obviously a higher acceleration will mean that we'll pick up speed really quickly. And so I'll just set this to a default value. We'll probably have to play with this to get the right value. Now by making this parameter public, let's see what happens. I'm going to use Control-S to save, and I'm going to switch back to Unity. Once Unity has focus, you'll see that it actually recompiles, And now it shows acceleration here, so I can use the Unity controls here to adjust this value, and I can of course type in a value here as well. So that's fine. It may not be a very good design decision to make this public though, because now that it's public, other components, other objects inside our software system could actually change that variable. So I want this to be private, but the problem is when you make a variable private, it's no longer available in the Unity inspector. So I've saved that, and I go back here, you can see that it's gone now. So in order to make it private but also visible, I'm going to add another annotation here called serialize field. And let's save that. So now it's private, so I can only access it inside the player input script itself, but you will notice that it still shows up. And in fact, Unity remembers the value from before. Okay, so we need another parameter. I'm going to use the same technique for this, serialize field. And this one's going to be called steering angle. This is basically how much the wheels are going to turn when we push left or right. So the way input works in Unity is you get a value between -1 and 1. -1 usually is to the left, and +1 is usually to the right on the horizontal axis. But 1 is not a very useful value. So what we're going to do is we're going to multiply that by the steering angle, and we're going to get an angle somewhere between 20 and -20. So that'll allow us to not only rotate our wheels, but also control how the physics components are driving our vehicle. Okay, so I'm also going to have another private variable. This one doesn't need to be edited in the inspector, but this is going to be our cart controller. So I'm just going to call this controller, set it to null initially. And what we're going to do is in the awake function, so I'm just going to start typing in awake, you'll see that there's an awake function, and awake is called when this object basically comes into being. So as soon as this object exists, we're going to immediately find the controller. So I'm going to say controller equals, I'm going to use a built-in function in Unity called getComponent. GetComponent searches the current object, so in this case this is our, what's it called, cart object. And it's going to look to see which components are on it. It's going to try to find one called cart controller. And you can see that's there, so it does exist. So I'm going to say cart controller. This is a type qualifier, so I'm specifically saying I only want to get components that are cart controller type. And that's all we need to do in our awake function. So pretty simple. All right. So Unity has various lifecycle methods. I mentioned this awake one. There's also a start one. Start is called when I start the game. So when I push this play button up here, it invokes start. But there's also another one called update. There's actually quite a few more. But update is a very useful one. This one is called literally every frame of our game. So if we're running at 100 frames a second, this is going to be called 100 times a second. So you want to be careful and try to use to be, conscious of what computation you're doing inside this function. If there's anything that you can pre-do, it's usually a good idea to do it. For our game, because we're not doing anything too serious, it's not going to be as important, but I'll mention a few things as we go. Alright, so this component is not actually going to control our vehicle, it's just going to collect the user's input, so let's first do that. So first what we're going to do is I'm going to collect something called the steer amount. And I'm going to do that by doing input.getAxis. There's actually these two functions, getAxis and getAxisRaw. And what you do is you pass to them the name of an axis that you want to use. So let me go back to Unity and kind of show you what's going on. This is not going to compile, of course, but I'm going to go to Edit Project Settings. And then in the Input Manager, we have this thing that you can expand here, Axes. And we already have two defined, one called horizontal. And you can see that horizontal is bound to the left and right button, which are the cursor keys. And they also have alternative A and D keys. So you can, this is the WASD, this is the side to side. And in the vertical axis, you can see that we have up and down cursor keys and S and W keys as alternatives. And actually, down here, you can see that there's another horizontal. And this is just a way for you to create even more if you want to. So this one you can see is bound to the joystick axis. This is bound to the x-axis of the joystick. And then the other vertical is bound to the y-axis on the joystick. So what's kind of nice about this everything is normalized to give you a value between -1 and 1, but using both will actually still control our vehicle. Okay, so anyway, that's the input system. So we're going to use those names when I use this. And I'm just going to say quote horizontal. Now there was another option, get access raw, and basically the difference between these two, if I just do get access raw, it's going to tell me the current value of the joystick, or the current value computed as a result of the keys that are pressed down. Like if you're holding left on the keyboard, then this value will just be exactly -1. Get access, on the other hand, will do a little bit of smoothing, which actually produces a nicer effect in the game. So for example, if I'm turning left and then I let go of the A button to stop turning left, it'll kind of smoothly transition into me going straight, which is actually a lot better. I don't have to do any of those calculations. Unity will do that for me. So that's what I'm going to use here. Sometimes you do want to use raw. Okay, so there we go. Steering angle is the steering amount is the first amount, and then we're going to do also power. Now these aren't great controls, but what I'm going to do just for simplicity is I'm going to use the vertical axis to push up and down on the cursor keys, or W and S, in order to add power or brake. Okay, so then what we're going to do is we're just going to behave slightly differently. So we have our controller. I haven't written it yet, so we're going to pretend that some functions exist. But basically I'm going to create a few basic functions that are going to handle the different scenarios. So the scenarios basically are, we're going to be steering potentially, we're going to be applying power, we're going to be braking, and we're going to be coasting. So imagine I'm pushing up on pushing W on the keyboard. That would mean that we're applying power, so I'm going to be basically accelerating like the gas pedal, I guess. And then if we're pushing the S key, that will be applying the brake. And if we're not pushing either one, then we're just going to be coasting. In that situation, probably we want the car to slow down like it would in a real-life vehicle. So we're going to handle that. And then the steering should be relatively simple. We're either steering or we're not steering, and the horizontal value will be 0 if we're not steering. Okay, so I'm just going to have a big if statement that's going to check those 3 conditions. So I'm going to check to see if the power amount is less than or equal to 0. Let's actually make it just strictly less than 0. If it's less than 0, that means that we're pushing down. So in this case, we want to brake. Okay, so what I'm going to do is I'm going to call controller.brake. Now there's no such function, so it's going to highlight it in red. That's okay, we're going to fill this in a little bit later. And then what I'm going to do is I'm going to pass in my power amount. Okay. Now this is actually assuming that you want to brake and accelerate using the same force. That's probably not going to be the case. For now, let's just leave this exactly the way it is. Okay, so now I'm going to see the power amount. Whoops. If the power amount is greater than 0. And in this case, I want to accelerate. So I'm going to call controller.power. And then finally, if we don't have either one, in other words, our power amount is exactly equal to 0, then I'm going to say controller.coast. Alright, so none of these functions exist yet, but we're going to have to work on those. Before we do that, though, I want to finish this one because this power amount is only going to give us a value between -1 and 1, and that might not be anywhere near enough. Now, I could adjust that inside the controller, but this is kind of an artifact of the fact that that's how the input system works in Unity. That's not necessarily the way our AI is going to work if we have an AI-controlled car. So I really want to adjust this power amount in this component. So what I'm going to do is I'm going to multiply that power amount by our acceleration parameter. That's the whole point of that parameter, is to provide additional acceleration. Okay, and the same actually goes for the steering amount. So for the steering amount, I'm going to multiply that times our steering angle. We didn't do the steering just yet. But again, because the horizontal value is just a value between -1 and 1, we probably won't even be able to notice an angle change of -1 or 1, so we're going to have to do something else. Okay, so I'm going to multiply that by steering angle, and this will mean that our wheels will steer from -20 degrees in one direction, and 20 degrees in another direction. Alright, so the last thing we're going to do is we're going to do the controller.steer, and we're going to pass the steer amount. Again, we don't have that function yet. But there we go. Now we actually have our first component. It is totally broken, obviously, because we need to fill in these 4 functions. But let's do that next. Okay. Just going to bring up a reference here. Alright, I mentioned last time that we need to make sure we have a rigid body, but we didn't actually use a rigid body in this player input script. So I just put it here just to show you that you could do more than one, but we don't need one here. It's just a good practice for each component that actually uses another component to require that component. So this one requires that we have a rigid body, so I'm going to paste this require component here, because without the rigid body we can't actually apply any real forces. Okay, so the next thing we're going to do, and I like my curly brackets in the right spot, I'm going to delete everything. Let's first put in our parameters. So what I'm going to do is I'm going to make it so that I can drop in a list of different kinds of objects as we go. So I'm going to have a set of wheel colliders, but I'm going to have 2 different types of wheel colliders, or really 3 different types of wheel colliders. I'm going to use the serialized field property for that, but I'm just going to have wheel collider, but I'm going to make it an array so that we can have more than one. And the first one I'm going to call it is called power colliders. And these are going to be, I'm going to drag in the wheel colliders for the wheels that I want to apply power. So if it's a 4-wheel drive vehicle, I'll put all the wheels in there. If it's just a front-wheel drive vehicle, then I'll just put the front 2 wheels in there. This will make our controller a little bit more usable in other situations. I do want to have other types of carts. I'm also going to have an array of wheel colliders for steering. We'll call these steer colliders, say. And the steer colliders, again, are the ones that are going to make the wheels turn. So this is just going to be the front wheels in our case. And then we're going to say serialized field, wheel collider array, and this is going to be brake colliders. Now the brake colliders are going to be all the ones that have brakes. We can probably assume that we'll have all-wheel braking. This is a race car after all, and so that's probably what we'll do, is drag all 4 wheels into there. But it's flexible now. Okay, we're also going to do the same thing for the geometry. So I'm going to have a transform object. I showed you what a transform object, a transform component is. So every single object in the game is going to have a transform component. So I'm going to drag in the geometry versions of the wheels for these, and you're going to see kind of a similar pattern. So first of all, we're going to have steer transforms. These are wheels that are going to steer. And then I'm going to have an array of transforms called non-steer transforms. Now I'm not applying power to any of the geometry wheels, but all the wheels are going to rotate. So the powered wheels are going to rotate because the engine is rotating them, but also the non-powered wheels are going to rotate due to friction on the ground. So I basically want to rotate all the wheels. So this is probably going to contain all the non-steering wheels, and the only thing I'll do is just rotate them. So it looks like they're spinning. And steer transforms, I will do that and also handle the steering rotation. Okay, and then finally I also want a separate object for the steering wheel. So it's a little bit confusing, but by the steering wheel I literally mean the steering wheel inside the vehicle, the one used to control it. I want that to rotate as well. So eventually when, now that we just have nobody's in the car, I can actually really closely see that. Maybe we won't want that steering wheel to actually rotate when the game is done because we'll have somebody sitting in this seat, and I don't know if we'll be able to see anything. Okay, so this will just be a single transform, and we'll call this steering wheel transform. There we go. Now one more thing we're going to do here is I'm going to create another parameter. Now I'm rotating them, and basically kind of a cheap way of doing this would be to just have a floating point, and I'll have something called a wheel rotation factor. And basically this will allow me to like speed up or slow down the wheel as the vehicle moves. So I can have some kind of rotation speed that's based on the speed of the vehicle, but bigger wheels are going to rotate more slowly than smaller wheels are. So I can actually assign different wheel rotation factor, but in this case, this is just a kind of a cheap way to achieve the rotation at all, and we'll probably tweak this a little bit later. We'll add some more realistic. We could actually calculate using the math, using the circumference of the wheels, the geometry of the wheel. But for now, anyway, we'll just do this so we can see it rotating, so it looks pretty good. All right, so then we're going to have some private variables. We're going to have power torque, and torque is similar to a force, but it's applied rotationally. So we're just going to this is going to be the amount of torque that we're going to apply to the powered wheels. You definitely, by the way, want to have to make sure that your power colliders are, symmetrical side to side. Okay, and then we're going to keep track of our steering angle. Again, that's just for the steering wheels. And then we're going to have brake torque. Brake torque is going to be a different amount from the power, although we are going to put some code in there to make sure that we're not applying torque and brake at the same time. And then we're also going to have the rotation angle. Okay. Now, just for my purposes, just so I can see to make sure everything is looking nice, I'm going to have a variable that I can see in the inspector, but I'm not going to change it in the inspector. You can actually use properties for this purpose, but I don't want to introduce too many language features too soon. This would be a really good candidate for a property because we could make this a read-only thing. All right, one more private variable, which is our rigid body. I'm just going to call that RB, pretty standard in Unity development. Okay, so we have required that anything that has a cart controller on it also has a rigid body. That includes an AI controlled car as well. So I'm going to use the awake function just like we did in the other component in order to initialize this rigid body. So I'm going to say get component of type rigid body. Do it in the awake function. I know that anytime I'm executing, say, in the update function or whatever, I know that RB is going to exist. Okay, so then now let's make those 4 functions that we defined. So these aren't going to do too much. I'm going to make them public. Because just like I was talking about before, when you make things public, including functions, that means that you can execute them from within other objects. And so even though this is technically the same game object, it's a different component, and so this is a different class. So therefore, I can have a function called steer, and steer takes a, this is called an angle. So let's just save that, and you'll see if we go back to our player input, you see that the steer function now is no longer highlighted in red. So maybe the best thing to do is get rid of that red. I don't know about you, but I like getting rid of my errors as soon as possible. So we'll make a power function. I'm going to make a brake function. And finally a coast function. There we go. So now we've got all the functions that we're going to need. There should be no errors over here. Everything looks good. So now let's fill in some of the code. I need one more function. We're going to need to do the update. The update's where the actual behavior is going to be. These other 4 functions are just going to set the values. So in steer, what we're going to do is we're just going to remember the steering angle. If you remember, we have a private variable up here for the steering angle. So I'm just going to set steer angle to the angle passed in. That's all we need to do. In the power function, we're going to set the power torque equal to the power amount. And I'm also going to make sure that if I step on the gas, I want to not step on the brake. Okay, so I'm going to set the brake torque to 0. And for brake, I'm just going to do the exact opposite. So for brake torque, I'm going to set the brake torque equal to brake amount. And I'm going to set the power torque equal to 0 if I'm braking. So we're not going to be pushing the gas pedal and the brake pedal at the same time in our kart. It's kind of hard to do with the W and S keys anyway. Okay, so next is going to be coast rather, and so what I'm going to do is I'm going to just hard code in a coast braking torque, so that'll cause us to slow down. Now actually there are frictional forces and there are drag forces that are being applied to our object. They're not going to be particularly accurate because the box that we have doesn't really match the shape of the vehicle. I think so what I'm going to do is I'll just create, you know, I'll make it configurable. I'll say serialized field float, and we'll say this coast torque, and I'm going to set this to 50,000. Okay. Alright, so then down here in the coast, we're going to say brake torque is equal to coast torque. And of course, because we're coasting, I'm going to turn off the power. There we go. So that's not going to do anything. But I can then use those variables in the update function. So again, this happens every single frame. So I have to be careful not to do too much here. First thing I'm going to do is update the current speed. So this could just be a local variable, but I made this a visible parameter in Unity so that we can kind of see what our current speed is. By the way, Unity uses all metric system units, so it's in meters and meters per second and so on. So we can actually just ask the rigid body for our velocity. So rigid body has a parameter called velocity, and this is actually a velocity vector. And if we want to know how fast we're going but not necessarily the direction, then we can just get the magnitude of that vector. So the length of the vector is the actual speed. Okay, so then what we're going to do is I want to rotate the wheels. So I'm going to say rotation is equal to current speed times time.delta time. Let me explain that in just a moment. Times our wheel rotation factor. So this update, as I said, happens every single frame. But the frame rate in a game might be very different. So somebody might be running it at 30 frames a second, somebody else might be running it at 110 frames a second. In those situations, the amount of time that has passed is very different, right? So in a higher frame rate, the amount of time that has passed is much, much smaller. This current speed here is about our instantaneous velocity. It's based on our instantaneous velocity. So if we actually multiply that times the wheel rotation factor, we'll get some value, and that value is the same regardless of our frame rate. So that means that we'll push forward a little bit, we'll rotate our wheel in this case, a little bit, regardless of what our frame rate is. And so if I'm doing more frames per second, I'm going to do that more often. So you have to make sure that you scale things according to the frame rate by doing this time.delta time. What delta time is, it's a floating point value that says how many seconds have happened since the last call to update. So this is basically how much do I want to move just between last frame and this frame. So that's what we've got going on here. Okay. So now that's the new rotation amount. So what I'm going to do is add that to our rotation angle, which is, rotation angle. Okay. So the first thing we're going to do is I'm going to add the acceleration torque. Now to do that, what I'm going to do is go through each one of our wheels. So in this case, we have certain wheels that are used for power, our power colliders here. So I'm going to loop through that list. So I'm going to use a for each loop for that purpose. I'm going to say wheel collider. We'll call this wheel in power colliders. So this will loop through all that list. It's going to be set to an empty list when we first start, but we'll make sure that we pop in those wheel colliders after we switch back to Unity. Okay, so what we're going to do here is I'm just going to say for that wheel, I'm going to set its motor torque equal to the power torque value that we set in the power function. There we go. Okay, oops, for each. And we're going to do basically the same thing for braking. I'm going to go through all the wheels that are in the brake colliders. This should probably be all the wheels. And by the way, it's perfectly fine if a wheel is in more than one of these sets. So yeah, of course, the wheels that are going to power the vehicle are also going to be wheels that are going to brake. Okay, so we set the brake torque. Now remember, because of our other functions, we made sure that at any given time, at least one of brake torque or power torque is 0. So we're going to be either braking or accelerating, not both. Next thing we're going to do is we're going to add the steering. And so I'm going to loop over the wheel collider list. And this is going to be the steer colliders. Same kind of deal. Just going to set the steer angle to steer angle. Okay, now we're not done, but let's check it out and see what this does. I think there's going to be some surprises for us, but let's try it out and see what happens. Okay, so there we go. There's our game, and we push the keys, pushing it, and if we look over here, just for the purposes of debugging here, you can see that it actually is kind of changing over time, but it's a really small value anyway. And the reason is, oops, I forgot to add the power colliders and the steering colliders and so on. So first let's add the power colliders. So when you have an array in Unity, if you expand this and you type in how many, so let's make this, I don't know, this could be a 2-wheel drive vehicle. Let's make it rear-wheel drive for whatever reason. And then what we're going to do is not the geometry, we're going to add the wheel colliders. So I'm going to add the left rear wheel and the right rear wheel. And then the steering, we're going to make that our front wheel. So I'm going to say left front wheel and right front wheel. And then the brake colliders is going to be every single wheel collider. So let's drag in all of the wheel colliders for that. We have to do the same for the geometry, but we haven't written that code yet, so. Okay, so there we go. We haven't done any of these things yet. All right, let's give it a go. Just going to scroll up so that we can see our current speed. Let's close this so that I can see a little bit more. Okay, so now if we push W, you can see I'm actually pushing W, and that's making my current speed higher, but it's actually making our car move backwards. So let's go into our wheel colliders here. And let me scroll around so I can see this a little bit better. Okay. Okay, so that's our wheel collider, and we can actually see it there. So I think this collider needs to be rotated. So the rotation should be on the y-axis here, so let's do, there we go, and we'll do right front, same kind of deal. Pretty similar to the wheels, I guess that makes perfect sense. So let's do the right rear wheel here. Just going to flip that on the y-axis, and the left rear wheel, flip that as well. Okay. So now going back, let's set the acceleration. This is really too slow. Let's set it up a bit more. We'll probably have to set it even more than that, but I just want to see it move. The camera is not currently bound to our vehicle, so I want to make sure this doesn't get out of control. Whoops, this doesn't seem to be making a difference. Okay. Okay. So figured out what to do to fix this is just in here in the cart controller I set the motor torque to negative, the negative value. Okay, so let's give this a quick test. So we push W and it starts us going forward, we push S. Woo! That's the problem with testing it this way. Okay. Okay, let's move the camera maybe back a little bit. Just to make sure we're braking in the correct direction. Keep going forward, hitting the brake, stopping. Here we go. Going forward, hitting the brake. Ooh, it's not stopping very fast. Okay, so I think what we need to do, and I needed to do this in my testing too, so it's not overly surprising, is we need to set the brake amount to be more. So let's actually add a parameter for that, rather than just hard code it. We'll call this brake factor. And we'll just set it to 2. So when we brake, we're going to multiply the power amount by the brake factor. It makes sense that we're going to want to stop much more quickly than we're going to accelerate. We should be able to do that in a fast car. Okay, didn't start braking until too late in that one. Okay, let's keep looking here. There we go. Okay, I'll just let it dry for a little bit. Okay, seems to stop and start. It's kind of tiny. Alright, let's actually just attach the camera to the cart. So we're going to just do that. And then you can see the carts, we're viewing it from the front, which is kind of strange, but let's fix that, I guess. So we'll just move it over here, and we'll rotate it 180 degrees. There we go, we're kind of behind the car, looks fine. Alright, so now we'll just drive forward. And let's try the steering. We got A, D. D turns us right, A turns us left. If we let go of the W key, we coast. If we hold W and hit S, we brake. It's braking really slowly. So the coast braking is working fine. It's just we need to tweak the amount of actual braking that's applied, so we can easily fix that. And if you think about it, I had arrived at a coast braking value of 50,000. And so when we brake, we're obviously going to need a brake factor that's at least that amount. So we'll put in something like, I don't know, since we're multiplying that times our acceleration, we could do something like 2,500. Let's give that a quick test. I'll use the cursor keys. Just let's get some actual speed going first. Push down. Nope, that's not working. So let's actually use a little bit of problem solving to figure out what's going on here. So, okay, it's a very good idea for us to see what's going on. So what's used to be the most basic technique I can think of is we're going to figure out the break amount here, and I'm just going to output the break amount to the console. And let's see what it is. Let's do it down here as well. Let's differentiate these two, I guess. Alright. So now keep the console open. And clear on play is set, so it's going to clear. We should actually see this coasting value. Now that we're moving, there's no new log messages. I let go, and we're coasting. You can see the coast messages increase. But let's again push up, and then I'm going to push down so we can see the values here. So the values are actually negative values. Whoops. Messed that up. And that makes sense because we're actually getting a negative value from this vertical amount here. So we should change that. Okay, so I think the best place to do that would be up here. We can actually just change the break factor to be negative. Kind of makes sense. And let's give that a go. Okay, so accelerating. It's not a really good angle of our vehicle right now. Okay, it maxes out at 1,000. It maxes out at 1,000. So we're multiplying the power amount by the brake factor. By pushing down, we're going to have a -1 value here at the maximum, and we're going to multiply that times brake factor. So then when I call brake here, brake amount braking maxes out at 1,000. That's not what I would expect. Oh, this negative here didn't actually take effect, because silly me. That's why it was capping out at 1,000. Okay, let's save that. That was kind of a new mistake. Sorry about that. Alright, so let's accelerate forward a bit. You can see why I have the checkerboard now, so we can see our car in action, see if we're actually moving. It wouldn't be that obvious if we weren't. Alright, and let's brake. So you can see we're getting huge braking values, which is good. Alright, let's accelerate. Our acceleration is torturously slow, so we're going to obviously have to bump that up. We want our car to go a lot faster. Alright, let's change this to 5,000. Ooh, it's still really slow. I mean, I suppose it makes sense that we should have somewhere in the hundreds of thousands like our brakes. But these enormous values. Alright, so let's make it 200,000. Still kind of a really slow speed. You can also see some camera effects, and that's caused by the physics engine interacting between the wheel colliders and the colliders of the ground. We'll fix that issue a little later with a nicer camera. But anyway. Anyhow. So yeah, you can see the vehicle moving around, but you'll notice that the wheels aren't rotating, and the steering wheel isn't rotating. The wheels aren't steering, so this is not an ideal situation. Okay, so we have to then fix that. So this is just a matter of getting the geometry working out properly. Okay, so in the cart controller then, so this section, this is the physics section. Okay, and actually, as it turns out, the best way to do physics behavior is in another function, which is called fixed update. And the reason why is because fixed update is called every single time the physics engine is updated. So what I'm going to do is I'm going to move all of this stuff into physics update. Okay, we're not using any of these values just yet. And that should make things a little bit more efficient. Now, okay, yep, that seems pretty good. And then this update is called whenever the graphics are going to be updated. So changing things like the appearance of the wheels, which is what we're going to do next, does actually make a lot of sense. Okay, so next thing we're going to do is let's make the steering wheel rotate. So I'm going to say, first of all, let's remember the steering wheel. Actually, let's put this in its own function. Okay, so we're going to have an X rotation. I'm going to say steering wheel transform dot local rotation. I think we've talked about this before. The local rotation is the rotation with respect to the coordinate system of the object. So if the object is inside a hierarchy of objects and its parent objects also have rotations, this will be like the inherited rotation from that perspective. So I can actually do global rotation or local rotation. We want to do local rotation because I want to rotate this wheel with respect to its own axes, and that way it won't rotate in some bizarre way just because our vehicle is tilted or whatever. Okay, so then the rotation is a quaternion, which I can convert to a set of Euler angles, and so I'm just going to grab the X and the Y rotation from that. And we're just going to set the final rotation. So I'm going to say steering wheel transform dot local rotation. And we're going to create a new quaternion, but we're not dealing with quaternions really in this section. So I'll just set that using some Euler angles. So what this does, it basically sets an arbitrary 3D rotation based on amount that we want to rotate about the x-axis, an amount that we want to rotate about the y-axis, and a separate amount that we want to rotate about the z-axis. In this case, the steering wheel is only going to rotate on the z-axis. So we're actually going to say x rot, y rot. So we're just keeping the existing values, and then we're going to go steer angle. And I think what I'll do is I will exaggerate this a little bit so we can see the effect. Okay, put a little semicolon there. And we'll call this function down here. So we'll say update steering wheel. Alright, so this, as we push left and right, we should be able to see our vehicle move. And our game view is not the greatest right now, so let's move our main camera up so that we actually will be able to see. And let's even rotate it down a bit. Okay, so we should be able to see. Maybe this is even a bit too far away. Okay, there we go. Now we should be able to see the rotation. Make sure that it looks correct. Okay, so we can see it here. Whoops, I forgot something pretty important. And I do this almost every time. Sorry about that. The steering wheel transform needs to exist. So I'm going to drag the steering wheel here into the steering wheel transform. Probably going to do the same thing with the wheel geometry too. Okay, so there we go. Now we can see the wheel rotate. Alright, now it is very jerky, as you can see, so we can apply some smoothing to it, but given that this is like a really low poly game, probably not going to see the steering wheel most of the time. I'm not too worried about that. It is computationally expensive to do some of that smoothing, so right now I just kind of want to avoid that. Alright, so now we'll set these steer transforms and non-steer transforms before I forget. So we're going to have two steering transforms. These are basically the geometry of the wheel that are going to steer, and these are the geometry of the wheel that are not going to steer. So what I'm going to do is I'm going to take the left front wheel, that's a steering element, and the right front wheel, steering, and the left rear wheel, non-steering, and right rear wheel, non-steering. And then we'll go into the code and make some changes. No, at least I won't forget. So what we're going to do then is we're going to update the, let's call them the control wheels, because it's a little bit confusing that we have steering wheels and wheels that steer. So we'll have two functions. We'll say update non-control wheels, let's say. And we'll just create these functions up here. Update control wheels and update non-control wheels. There we go. So the non-control wheels are actually going to be pretty easy because they're just going to rotate in the z-axis as a result of rolling on the ground or the engine powering them. So I'm just going to loop over these wheels. I'm going to say over the transform. I'm going to call these non-steer transforms, and each one of the objects in that list is going to be a transform. And so we're going to say wheel dot local rotation is equal to quaternion, and again we're going to use an Euler set of angles so that we can specify the x rotation, the y rotation, and so on. Now in this case the x rotation is 0, the y rotation is 0, and the z rotation is the amount of rotation that our wheels have rotated. So we'll call that our rotation angle. That was the variable that we're keeping track of up here. So there we go. So now this wheel will rotate. Now if we actually just copy this code exactly as is over here into the update control wheels, but change this to steer transforms, then these wheels will also rotate on the z-axis. So let's take a quick peek at that. We're obviously not done because we need to also do the steering. But first things first. Alright, so for the main camera, I'm not going to be able to see these wheels rotate unless I'm looking at it from the side. So maybe let's rotate it about the y-axis a bit here. Whoops, this way. There we go. It's a weird position for our camera in our kart game, but we'll change it back later. There we go. And that's not the greatest for lighting, so maybe we'll turn a bit to see if that's working. And okay, not a great angle. Kind of seems like it might not be working there. So let's see if we can fix that. And let's put it down as well. Alright, hopefully that'll work. You can see that. Definitely not rotating at all. And this one seems to be broken. You can see that it looks fine right here, but we are overriding a rotation. I think I know the reason why that is, because this is the right rear wheel, and its rotation was 180 here. So that's actually not going to work. So I think what I'll do is for these wheels here, I will do the same thing I did above. So I'll remember the rotation. So I'm going to say the wheels local rotation dot Euler angles dot x is going to be our x value. Same thing for the y value, and we'll use those y values down here. That way I won't forget the rotation that we had previously. And for now, let's just copy all of these into this code as well. Okay. Alright. Now it's not working, but at least the wheel is facing in the right direction, so that's something. The rotation angle is being updated by some amount, and the current speed, the rotation factor is set to 0, probably still is set to 0. So that would obviously do it, because that's the amount of rotation that we want to do. So the wheel rotation factor, let's set that to something like 10, and just see how that works. We'll tweak this value to make it look good, but okay, so you can see the wheels are rotating. That looks fine. Obviously the wheel rotation factor is not fine, so we need to adjust that. Let's make it something like 150. Too much. It looks kind of amazing though. Look at the spinning rims. Okay, let's set it to 50. Nope, not quite. There. That seems to match reasonably well. Now these shouldn't be the same for both wheels, but it's a decent start. Okay, so now let's move our camera around to the other side to make sure everything is going well over there. So I'm just going to pop this over here, and we'll rotate that so we can see on the other side. Alright, here we go. Okay, just wanted to make sure that they're actually rotating in the correct direction. You can see it's a little bit of a wheel slide there, so it's not quite the right value, but close enough for my happiness. Okay, anyway, looks good. So the final step is to do a rotation for the wheels that control. So in our update control wheels script, we're going to change that a little bit. So the steering wheels are going to be adjusted using the steering angle here. Okay, and so we don't actually need this X value here. We're just remembering the Y rotation if there was one. Okay, so now we're going forward here. Whoop, that is clearly incorrect. That looks crazy. Okay, so now let's look at our scene for a second here. Actually, let's stop. Let's look at our scene for a quick second here. And we were looking at this wheel over here, so let's just keep looking at that one. This one was clearly wrong. So this is the left front wheel. If we click on the wheel itself, a rotation in the y-axis actually is the correct rotation that we want. So we messed that up. Not that it's your fault at all, of course, but I'll bring you in with me. Okay, so I'm just going to move this out here, and we'll store the Z rotation. Here we go. So wait for that to compile, and there we go. So, whoop, that is like so wrong. The wheel is just rotating around. What did I do? So clearly in this case this is the wheel rotation, and I think when we're turning, yeah, so the turning is also incorrect. So what did I do there? So the steering angle actually is should show the local axis. I think that's what I did wrong last time. So in this case, we want to rotate about the y-axis for steering, and the z-axis is our rotation angle. Okay, so actually I had that completely wrong. We want the x rotation, which Next rotation. There we go. Alright, let's give this a go. Here we go. So there's our rotation, our wheels turn. There's no mechanism. Don't look too closely at the wheels because there's no mechanism to actually rotate them. There's no like machinery that actually turns the wheel. So, but you know, for a low poly game, this is actually all right. Alright, now these wheel colliders, I'm going to stop the game, but these wheel colliders do actually have the ability to do things like side friction, forward friction and stuff. So for example, if you accelerate too much, the wheels could spin if you set the friction really, really high. And you can go into slides as well. So these parameters will be something that we'll end up tweaking a little bit later on. Similarly, another thing that you might do is if we turn suspension back on, the reason why I didn't do that is because we currently have some geometry that we have to reflect. What would happen is the whole car would move down and up. If we turn the suspension on, it would do a little bit of bouncing. What we're going to have to do is, first of all, we'd have to change the geometry of this wheel so that it would show that bounce along with the collider. But also, we would need to dampen some of that bounce into the car's rigid body. So the car's rigid body right now is literally a rigid body, meaning it's just going to absorb all of that bounce from the wheels. And we don't really want that. What we want is the vehicle to absorb some of the impact, and so there'll be a little bit of a shake when the vehicle collides with the ground, and eventually it'll normalize. Right now it's sort of like bouncy like a ball, and that's why we have the suspension turned off. But to also represent that in a graphical way will require a little bit more effort. I don't know if that's really worth it for the simple game that we have going on. Alright, so for today that's all I've got. I hope that this taught you a little bit about Unity. We are going to keep going with this, obviously. I think the next time we're going to have to do another Blender video where we create some components for a track, so that we can create something that's reasonably fun. So we'll create some corners and some straightaways and ramps and things like that we can try out with our car. Alright, so I would suggest between now and the next video to play around with your car. If you ended up creating another cart in Blender, as I'd recommended, see if you can load that in and get it driving around as well. If you want, you can keep this cart in your scene. You can just sort of disable it by clicking this button right here, and then the object is effectively gone, but all of your code is still there. And then you can make some changes as needed and see if you can get your car driving around. And you probably want to tweak all the the rigid body parameters here and the wheel collider parameters and so on. Tweak those so that this car can drive around nicely. Alright, and don't forget to post it. If you post it with the experiments in CS hashtag, then I'll see it and comment on it. Alright, see everybody later.